Hello, everyone. Welcome to Skkewtosis. Today, our topic of discussion is equity option valuation using local wall. Right? So, before we delve into how an equity option is valued using Black-Scholes discrete and Black-Scholes continuous, first I'll quickly give you a glimpse of what exactly is a call option, right? So, as you might be aware, even if you are not aware, call option is basically gives a buyer an option to buy a particular underlying, right, at a pre-decided strike price at the option expiry, and the payoff of the buyer is given by max of 0, st minus x, while the payoff of the call seller is minus max of 0, st minus x, right? So let's now you want to explore more about derivatives like call and put in more detail. It's all available in internet. What exactly is Black-Scholes in assumptions? I'm ignoring those descriptions in the, as a part of this video, but you can always feel free to explore and reach out to us in case you have any queries related to the topics. So today our topic of valuation is equity derivative valuation, and what we are going to price today is an Apple US equity call option for a maturity of 6 months. We have to price this option as of 30th December 22. The option is expiring in 6 months using Black-Scholes continuous and Black-Scholes discrete. When I say Black-Scholes discrete, I'm saying Geometric Brownian Motion. Black-Scholes continuous means Black-Scholes formula. Right. We have a risk-free rate of 4.72. If you have seen the video of us, how we bootstrap the SOFR curve, we get this rate from there. If you have not, refer to our previous video on how we bootstrap the SOFR curve, right? And how we get this rate out of it, right, for the underlying expiry date. The strike price is 120, number of shares is 1. Now we have to understand that how do we price it using GBM and Black-Scholes. So very simple. Before we move into valuation, I'll quickly give you about an important market data which you will see in day-to-day corporate world, which you'll be used to price these options. Is basically as on 12/30/22, this is a wall grid which you can see in my screen. This wall grid gives you the future prediction of the forward prices as of 30/12/22, right? So we are going to use the forward prices. This is from this is basically these are the market data, two critical market data which goes behind the valuation. One is the implied forward. Implied means something which is going to be in future, right? This is the implied forward, right? And this is nothing but the volatility, implied walls across different level of strikes, right? Or other way to understand that, different level of moneyness or different level or strikes. We have been given the wall across different expiry dates. So expiry date here, and then we have different strikes. So for our trade strike is 120 and our maturity is 30 June 23. So we can easily interpolate for our maturity and the strikes from this wall grid. Right. And what is the other thing which you require? Today we'll not be implying the Black-Scholes, we'll be applying the Black formula. Black formula uses forward price rather than spot price. So we already have the spot price quoted in the market. This is a market data. We got to use the implied forward and implied walls to price my option using Geometric Brownian Motion and the Black-Scholes. Okay. So if you see, I'm first showing you the Black-Scholes formula. So as per if you see what we have done as of 36/2023, right, and for a given level of strike, right, we have interpolated the walls as if the strike of 120, right? We have interpolated the wall and the implied wall comes out to be 38.16. Then we have calculated D1, And D2, if you're not aware of Black-Scholes, right, D1 and D2 is something which I always say you can consider it to be a Z value, right? To get a proper intuition, it's like more of a Z value. It's like mu minus sigma by mu minus sigma by it's mu minus it's x. No, if Z value is basically what is x minus mu by sigma, something very similar to this, right? Like it's kind of D1 and D2 are kind of Z values, okay? We'll talk about this once you are with us in detail, like what exactly is all these components are. So we calculate D1. D1 is nothing but, if you see, it's ln F by K. The forward price is as of 30th June 23. Strike price is this. And then we have the volatility to be 38.16%. Right, so it's ln F by K plus sigma square by 2 into T by sigma root T. Similarly, we calculate D2 and D1 is nothing but the CDF of D1, and it gives a CDF of D1, and ND2 again gives a CDF of D2, and then you can just apply the Black-Scholes formula. Right, Black-Scholes formula is nothing but forward into ND1 minus strike into ND2, and then you just do the discounting, right? If you see, this is a NPV, this is a third-party NPV, difference is 0.0876%. Now quickly come to how do we simulate the stock price and compute the value of this payoff. First, we have to calculate, so the equation, right, which we are going to use today, is basically this equation. So if you can see my screen, okay. So today the equation which we are going to use is the geometric Brownian motion for stock price. Okay. So, yeah. So let me quickly take you to this. This is what we are going to use today. So standing today, that is S0, and we need the stock prices as of 30th June 23. So we know S0, we have to calculate different STs, which we can see at the maturity. We already know the sigma, okay? The sigma, basically because we are just valuing it in 6 months, we'll be straight away using the implied vol. But had it been more simulations, right, more time steps between the spot and the option expiry, we would be using the forward vols as a proxy of local vol. Right, so we need to calculate mu. We already know sigma, and WT is nothing but a Wiener process, right? So what we are doing, the growth rate here is mean, which we need as you saw in that equation, and that is nothing but forward rate by the stock price as of today, and you just annualize it, and right, and you get the annualized forward rate. We know the vol is forward vol, okay. So if you see ATM vol, so whenever we are doing simulation, right, we got to use ATM vols because average of the stock price simulator should be equal to the market, implied forward, which you actually observe in the market. So ATM vol is 36.16. Here we were using the vol when we were using the Black-Scholes continuous. We were using the vol as per the strike, but when we are simulating, we got to take the vol as per at the money level, okay? Now we know that, okay, at the money for 30th June 23, 36.16 is the vol. Growth rate is nothing but 3.80. And we just apply this equation which I showed you. Right, so current spot price, that is S0 into e to the power mu, that is the growth rate, minus half into sigma square by 2 into T is nothing but the maturity in terms of years plus sigma into square root of T into random number, the Wiener process, right? This Wiener process is going to make your stock price stochastic, right? So this is how it is done, and we gotta do this. We gotta generate thousand or 10,000 stock prices, right? Similarly, what we have done, this is for another, this is another stock price generation using a different random number, right, for the same date. So once we do the simulation, you see we have simulated close to 20,000. So 20,000 stock price as of 30th June 23, standing on 30/12/2022. Once we know the stock prices, right, using GBM, what we have to do, if you remember, right, if you remember that call option payoff is what? Max of 0, st minus x. St is what we have generated using geometric Brownian motion, and geometric Brownian motion is the method, but how we simulate is Monte Carlo. Right, and we know the stock price, strike price 120. We gotta just apply this formula at we gotta just apply this formula. If you see what I have done, max of E9 minus strike, that is ST, the stock price, simulated stock price minus strike price, comma 0, right? I just do the average, I calculate the payoff across the 10,000, 20,000 stock price, and I just do the average. This average value is my market value, right? So if you see, this is the third party value, our value is 19.08, difference is hardly 0.92 or close to 1 cent, right? So, and one thing, when I'm saying that, why we have to simulate using ATM, if you see our implied stock price, forward price is 132.07 as of this maturity, 30 June 23. And if you simulate using ATM, the average of your simulation should be very close to the implied forward. This is how you check that this is how you ensure that your simulation is correct. Thank you for joining today's class. Keep in case you have any doubts related to topic, feel free to reach out to us, and continuously streamed in. We will have some interesting videos and papers in coming months. Thank you.